So if you have a graph of a function and you draw vertical lines through it, if anywhere in the graph your line hits 2 points, not a function. And we went into detail on what is a function and gave you some examples. That was last time. Okay. The blank of a function y equal f of x are the values of x for which f of x is equal to 0. So when your f of x is equal to 0, in other words, when your y's are 0, these are called zeros. The zeros are the function. So if you hear that term, find your zeros, or the zeros of the graph, that's anywhere with the y is 0. So basically, anywhere the graph is touching your x-axis. Okay, does that make sense? Okay, so when now for increasing and decreasing, if a function f is blank on an interval for any x1 and x2, so if your x1 is smaller than the x2, so basically if the first x we're talking about is smaller than the next x, then and right, so this happens and we have the next y value being smaller, then that should be, let's see, I believe that's equal to, I have some doubts in my mind. And so if function is decreasing, if your first x is smaller than the second x, but your first y is bigger than your second y. So basically, all right, let me get my pen here. Like just so you can see what they're, it's hard to imagine that in your head, right? So basically, let's say I pick this point here as my x1. The location is x1, y1. This location is x2, y2. So you see how this x1 is smaller than x2, right? It comes before it. So if you see that, and you see that this y, which is also called f of x1 and f of x2, you see how this y, the first f of x1 is smaller than the second f of x2? Obviously, you can see from the picture, right? If you picture like a little car just going down, I'm using my cursor instead. Going from left to right, right? From here to here, we're increasing. As soon as we pass the peak, we're decreasing. So this decreasing section fits the definition right here that we're talking about. You see what I mean? Is that clear to everybody? Like the definition means and what visually decreasing means. Okay. So whenever you want to find increasing or decreasing, just go left to right and picture, a little car going up and down. If I'm going up the hill or I'm increasing, going down the hill, I'm decreasing. So you agree that from here to after this point, right? We are increasing. Okay. Alrighty, so I'll clear that then. Between any 2 points, x1 and f of x1, in other words, don't let that notation bother you. That's the same thing as saying x1, y1, x2, y2. Same thing. So finding the slope using this notation is also the average rate of change. So the slope through those 2 points is the average rate of change. The line through those 2 random points could be tangent, but I don't know. Let me see what this definition, this book calls it. Might be secant. Yeah, in calculus, we think the line through, well, no, they're right, never mind. Tangent would be if it was 2 points that are infinitely close. Secant was just 2 random points that you find the slope and you draw a line through it. But for example, if I just made a random figure, just random graph, who cares? Whatever. Right. If I connected this point and this point and I drew a line through them, they call this a secant line. That's all we're talking about. Okay. So that's a very brief rundown on the theory. Again, I recommend you watch the videos, look through the book, and then go through these examples with me. Okay, it'll make more sense that way. Now, we talked about this stuff before. Here's a graph. What is the domain? What is the range? What do you guys think? What is the domain here? What is the lowest x value that you see? Looks like here and here, right? Lowest and highest x value? Yeah, pretty much. You can write it that way, or you can write it as an interval with the symbols. But just in plain English, what would you say the range of all the x values that this graph touches? What would they be? Yeah, it looks like, let's see, 1, 2, 3, 4, 5. So this is -2. This is 2, right? Yeah, it looked like a 3 at first. Now the question becomes, so this graph does not go beyond these 2 values, right, on the x. The furthest it goes is all the way up here, and it stops, right? It's all the way from up here. That makes sense? Right there. Okay, anyway. So now if you, it says to write it in interval notation. So we have to decide, do we put a parentheses or a bracket on the -2? Do you remember the requirements? Yeah, that is an example of interval notation. Yeah, exactly. If it is an open circle, meaning a hole, you put a parentheses in this location. If it's solid, you put a bracket. So it's technically written -2 until 2, but we include the 2. So bracket means you go all the way until 2 and stop. Parentheses means you go all the way right before -2, like -1.999 is cool, but -2 is not included. There we get really close, but we don't go there. That makes sense. The difference between parentheses and bracket. I know, just reviewing just in case. Any questions on the domain? All right. Thanks. Appreciate your participation, guys, because talking to a wall gets pretty boring sometimes. All right, range. What is the lowest Y value and highest Y value? Yeah, it looks like -2, right? Right here. 7. So bracket on -2 because there is no hole here. It's right on there, and this one's solid. If this one's open, which is an issue, but since it hit it over here, then we're good. Doesn't matter. Does that make sense? All right, I'm gonna remember participation for extra credit points. I think that's what I will do. You guys cool on this example here? Let me know if you have any issues. Okay, so let me zoom out a little bit so I can see the graph. Can you still see that okay? It's not too small?
That's good. I did have a question actually.
Yeah, what's up?
So like, well, because on the homework, it's like it only lets me do like either parentheses or a bracket. Like it doesn't let me do both.
Try just typing it in. Let me see. I don't know, let me do it. Did we say the domain was -2 to 2 bracket? Yeah, I think if you type it, it should be fine. I think if you use the symbols, it might have issues. Although right here, can you see the symbols? It looks like you can click the alternate ones like this. So it should work like that or typing.
Okay, thank you.
Yeah, no worries. Okay. Do you remember what the notation meant for functions when you see this? What we said when you see these guys? Oops. And we said that means you're plugging it in, right? If you had the equation, you would plug it in and see what happens. Yeah, f of x equals y. So if you were to see this, right? This means basically that your x is -1, and then the output would be whatever comes out, f of -1. Okay, this is the input, which is always x, and the output is whatever you get. Right, input. Now, f of -1. So that's what I meant with the function. Yeah, the y value at the x. That's a great way to put it, Carlos. -1. F of -1. So here's -1 right there, right? What is the y value that is associated with this x here?
-2.
Yeah, so this is -1, -2. So that would be f of -1 is equal to -2. Okay, does that make sense? So basically you have the x and they want the y value. I just want to make sure you understand mentally or conceptually what this means, right? Graphically. The equation we plug it in, but graphically it's a location, right? It's the y output. It is the output of the function at 0. That's what this means. So at 0, the function is outputting here. 1. Oh yeah, there you go. Thanks. Is there any questions about that? Okay. So if this is okay, let's go ahead and move on then. I don't think there's any other parts on this guy. This is the same type of question. Let's just do the domain real quick and move on. What's the lowest x value? Yeah, the lowest one is right here. And the tick marks are halves, so yeah, you're right. That was a tricky one. So it's a closed dot. So bracket, right? How far does the function go? Looks like it shoots off forever, right? Yeah. So if it doesn't have a stopping point, then it's usually assumed or denoted with an arrow that it keeps going. Never put brackets on infinity though. Infinity is not a number, it's a concept. So you can't include it. Range lowest y value. How far does this go down?
Negative infinity.
So the lowest one always goes first, or most negative, which is the same thing. So negative infinity up until the highest point. It's here. Yeah, looks like 7. Do we include it with a bracket or a parentheses?
Bracket.
All right. Any questions on domain? See here. All right. Think of these piecewise functions or piecewise function. What's the domain here? I'm gonna assume it keeps going forever. So the question becomes, for the x values, the domain, do I skip any x values? Because it looks like it goes on forever in both directions, right? Does it? It looks like it skips one, but does it? Solid over here, right? So it looks like it does cover everything. It goes from here, it hits negative infinity all the way to 1, and then it continues right after 1, right there. So there's no missing pieces. But it looks like the one that we got to worry about is going to be the y, the range stuff, right? That's the one where it skips around the 1 area. So it hits all the y's up here, right? It keeps going from this 4 all the way up forever. It hits all these y's, and then it doesn't go down anymore, right? This one also goes up. So what do you notice? Is it infinity in both directions? Do we have a maximum or minimum?
The minimum would be -2, right? With the parentheses.
Yeah, it doesn't go below this point. Everything else is going up. So that'll be -2 up until. Yeah, I guess we're good. Yeah, -2, and then we keep going up. Right? Do we miss any y's? In the middle, I mean. Looks like we're hitting them all, right? It's very good. It's just that we had to figure out the minimum first. So maximum. It shoots upward. Does that make sense to everyone?
I have a question.
Yeah.
So, will it always be like that? Like if there's one open and one closed, but they're on the same line, will it always just count as closed?
Yeah, so if it's closed here but not there, right?
Hmm.
So that means that one is defined here at 4, 1, 4. But it is not defined at 1, -2, right?
Hmm.
But if you think about it, if they were both filled, wouldn't that violate the function definition?
Yeah, because then it would have two different outputs, right?
Yeah, so you have to have one open.
Okay. That was just one thing that always confused me when like writing out the domain would be like if there's an opening but also a closed, you put it as open or closed. But that makes more sense.
Just think of it in terms of, yeah, cool. Thank you. Thank you for asking, it's a good question. All right. One second. That is. Okay. So the mid range, making sense, right? I'm gonna move on to something else. Alrighty, let's move on to the vertical line test. Number 9, does it pass the vertical line test? No, right? No matter where you draw the line, it's going to hit twice. So whenever, if that ever happens, then it's not a function. So if you had a normal parabola, you can see that it is a function because it's only going to hit one time. Right? So no, not a function. This is called a relation, but not a function. So that's an easy way you can check is to just look at the graph. Is number 10 a function?
Yes.
Yeah, it looks like. Yeah, it looks like it's going to be a function. Vertical lines, no problem. All right. We mentioned something about circles, right? What do we say about circles?
they'll never be functions.
Yeah, they'll never be functions. Because all of them go to two different places, right? All the points inside. You can see it, right? All these X's in here are mapped to the bottom and top half of the circle. And easily you draw any line anywhere, it's gonna hit twice. Is this a function?
Yes.
Yeah, it looks like we're good. We do have an asymptote in the middle. But yeah, it's still a function. So let's move on. Is everyone comfortable with the definition of a function? Before we move on to something else. All right, 1 second. Sorry about that. Okay. So zeros. We should probably use the graph to help us out here. There it is. All right, so our question was y equals 3x plus 21. Okay. This final algebraic. So we can check our answer by just graphing it. But solving it, we just gotta do a little bit of algebra. It's not a big deal. So let's do it right here. So y equals 2, 3x plus 21. In order to find a 0, that means that, I mean, look at it graphically, right? It means that the function is on the x-axis because the y, the f of x is 0, right? I wrote that weird. So in order to find this, set the function equal to 0. Solve for x. So move over the 21. Divide by 3. Oops, I don't know why I wrote it that way. Easiness. So this is -7. That makes sense, like conceptually what it means by zeros? Cool. All right, let's go to the next one. Let's do a couple and then we'll move on. Yeah, you could factor 3, then divide it out, it'd be all right. Okay. This one requires factoring. So again, let's grab it for fun. No reason. F of x is equal to 2x squared minus 3 was 3x. So we have the answers right here. So we need to find them. Show how to get there. So again, you can see these points represent a specific x that makes them 0. There's 2 different locations that give you an output of 0. So we gotta find them. So set the original equal to 0. And factor it. How does I think AC method would be best. Let's do it over here. A times C would equal to 2 times -9, which gives me a -18. So then you look at the factors, -18, and sum them so you get B. So 2 times -9, -2 times 9. That's not gonna work, right? What's a good factor for 18?
6 and 3.
Yeah, it looks like 6 and -3, or -6 and 30. To add them up. So we want this guy, correct? The AC method says break the middle term into those two factors. So minus 6x plus 3x minus 9. So this middle term became those two. They were basically setting up the problem to be a grouping problem. So now factor the GCF out of the first two. Factor the GCF out of the second two. Factor x minus 3 times 2x plus 3. There we go. I skipped some of the steps here. You guys are comfortable factoring, right? You can also do brute force method if you really wanted to. I think AC is the best one for this type, but there are other ways. Now set each one to 0. Solve for x, that would be, oh man, can't believe this. Right, which is, this is your 1.5, right? Okay, so we knew the question the whole time, or the answer the whole time. The point of all the math questions are, how do you get there? What's the process? Is there any questions on this example? All right, cool, nice. Alrighty. All right, 15 and 16 is similar. The only thing I need you to know is when you're doing zeros for rational expressions. I guess we could do it right here. You set the numerator to 0 because the bottom cannot be 0, and the only way you will get f equal to 0 is if the top is 0, because the bottom can't ever make it 0. The bottom cannot create an output of 0. So just look at the top. Basically, just do this. Set the numerator to 0, and x is -5. Same thing over here. So this is the only zero of the function. So if you graph it, you'll see a point on the x-axis at -5, comma 0. So this guy, same deal. Okay. So you just set this to 0. Sorry, I have space for a second. Factor this to the brute force. What are the factors of 45 that add up to -14?
9 and 5.
Yeah, so then they both gotta be negative in order to add up to 14. So we'll solve each of these. And that's it. Those are your two x values. So you'll just type in 9, comma 5. Any questions on finding zeros? You see how it'll depend, the process will depend on what type of function you have. But basically, it's just, you're just doing algebra, right? Okay, so let me know. You can go over anything. You guys have any questions or desire to do 17 or 18? Still finding zeros. Do you see how you would approach it? Okay, you guys are good then? I'm gonna go ahead and move on. Eighteen. All right, let's do it. So when is this 0? Well, if the inside 0, then it's gonna be 0, right? So just take the inside. Set it to 0. Subtract your 8. That's it. That's the location where the function will be 0. Will output 0. Okay. Increasing and decreasing. The easiest way to do this is to just graph it. That's it. So let's do it. Negative half x cubed. Okay. Now, remember, I'm gonna zoom in a little bit. We said left to right. So from the left, I'm coming down. Right, all the way down here. So it looks like at this particular point, something happens, and then we start going down again. Do we ever increase?
No.
Yeah, it doesn't look like it. So I'm thinking we're decreasing from in two locations. From negative infinity, right? Way back there. All the way until that weird number, 0. Then after 0, we keep decreasing. So I would say we are not decreasing here. I believe we should be constant there. Okay. I would say, oh, look, the graph's right there. I'm stupid. Let's do union. Yeah, that's cool. Let's see if it likes it. Not like my idea here. Well. At that point in the center, it is neither increasing or decreasing. Because it levels off for just a moment. Then right after, it continues to decrease. But it does not agree with me. I think, I mean, I want to say that, Megan, but they wouldn't make it that hard. I think I'm the one making it difficult. Because in calculus, we consider this point right here an inflection point or a global minimum. I'm sorry, a local minimum. So we don't usually say that it's constant there, but because it's not like an interval, it's just a single spot. It probably wants me to do this. Decreasing everywhere, but not, and there is no constant. So I disagree with this answer, but we'll go with it. Because I'm overthinking it in this class. Here, I believe it should be constant, but let's see who likes it. I think it's the same issue. Yeah, it's not gonna take it. Okay. So if it's not a collection of points where it's constant, then we will not, we won't put anything in there. Does that make sense? Like if we had a graph. Like this, and then suddenly it starts doing a straight line. And then starts going up again. Like I know it doesn't look like it, but assume that's a flat line. We would be constant here. Increasing here because from left to right we're going up, decreasing over here, left to right we're going down. Okay, so that's if you see a chunk where it's flat, then you can say it. But here, it's a single point that I believe is constant, but we'll let it go. So we'll just think of it in terms of what's the word? It's more of a critical point or a minimum, either the same thing. So before 2, we're coming down, right? After 2, we begin to increase. So how would you write increasing? The interval for increasing. Yeah, we're increasing from after this point. So after here, right? We all, by the way, I didn't mention this. For X values, I mean, for increasing these types of questions on increasing, decreasing, constant, we're only looking at the X values when we write the answer. But we're looking at the entire graph, right? You see how before 2, oops, we're coming down. We are decreasing all the way before 2 up until 2. Then right after 2, we begin to increase. You see how you answer these? It's always the x's. Even though we're looking at the whole thing as a whole, the y's and x's, the answer is only written with the x's. There's no constant location, no interval of constant. Okay, you guys cool on 20. All right, let me know if something doesn't make sense, just let me know.
I actually did have a question.
Yeah, what's up?
So, like, why wouldn't you use the brackets if it's a closed circle?
Yeah, that's actually the issue, the same issue that I was dealing with. Because at this location, oops. It's a great question. So right here, it is technically constant, it's flat. The slopes are negative all the way down. If you were to draw tangent lines, But then right after we start to increase, but what happens at that single point? It's neither increasing or decreasing, so you can't include it. So we have to put parentheses because it's technically flat right there.
Okay, thank you.
So in all the questions, you won't include the points where it changes from increasing to decreasing or whatever. You will only include the ones, you'll put parentheses on them. This one's a little harder. Let's look at it. From left to right. So picture a little car just going, right? So from here to here, we are increasing, right? Flat. Decreasing. Flat. Increasing. Can you tell me the interval for decreasing? Decreasing. It's from 0. Yeah, that's right.
0 to 2, right?
Yeah. Only one spot, correct?
Yes.
Increasing, we have 2 spots. So where are we increasing?
Would it be negative infinity to 1?
Negative infinity all the way until here. Because here it changes. So increasing from negative infinity until 0. Remember, look at the x's. The y value is 1, right? Not the x. The next chunk would be, yeah, let's see. Yeah, 2. So right after the 2, we begin to increase. So what you would do is put a union symbol and say 2 until forever. That makes sense? Yeah, don't put brackets on where it changes. Here we get a flat spot finally. So here, where would we be constant?
-2 to 2.
Yeah, -2 to 2. And then increasing would be over here. So what's the interval for increasing? Yeah. What about decreasing? Remember, it's always the lowest one first, so we would put negative infinity up all the way up until -2. So we're coming from way out here and landing there. Smallest always goes first.
Yeah. Because the elevators have.
All right, it's the same type of stuff. Here's the last set of problems. Average rate of change. All that is a slope formula. Slope. So the average rate of change is equal to, from the bottom is still x2 minus x1. From the top, you have f of x2 minus f of x1, which is basically y2 minus y1. You see what I mean? Here's the x1, x2. Plug them in to get your corresponding f of x2, f of x1. But on a line, it's kind of boring. Only the average rate doesn't change because it's a line. So the slope will be the average rate of change because it is a slope formula. So if you use a slope formula on a line, you get the slope, which is right there. So let's do it on this one instead. So we need y2, x2. I'm sorry, y2, f of x2 and f of x1. So in order to find them, solve these, and then we can just plug it into the formula, right? So 36 minus 24 plus 8. What is that going to be? About 5. Right. 1 minus 4 is -3. Are they both 5? Or is the bottom one 5? Yeah, I got that for the bottom. What do you guys get for the top? 20? All right, thanks. I'm too hungry and tired and I'm not gonna do that in my head. So, 20 minus 5 is the outputs, so they're right here, right? Divided by 6 minus 1. Yeah, I guess so. So. So the average rate of change for the parabola, right? We're doing this one. Between those 2 points is 3. It's also the slope of the secant line that connects those 2 points. Okay, so let's put a visual to this. What the heck does this mean? Well, at x equal to 1 and x equal to 6. All right, so this, ignore those vertical lines. I was trying to, you know what? I'll just write that myself and then delete them. So the slope of the secant line is basically, so this is the idea, you connect 2 points. And you try to find what is the average rate. So the average rate between, totally missed that. Let's use this. So you have a line connecting that line. The slope of this line is 3, which represents the average rate of change of this function from 1 to 6. So from 1 to 6, that's the rate. Does that make sense? So if this was like a velocity function, and you had your velocity changing over and over again, the average velocity from point 1 to point 2, or point A to point B would be 3. There was some like physics kind of problem. All right. Well, that's pretty much it for this section. I didn't think we'd take that long, but sorry. Any questions on analyzing graphs? Okay. Well, we'll stop here. If you have any questions or concerns with the exam or homework issues, stick around and we'll figure it out. If you're good, then I'll see you Wednesday.